so the title of today is the normal distribution. This first part, you don't need to memorize it, but a continuous probability distribution, it occurs when the outcome can be any value in an interval. So that will never show up on a test or a quiz, but I'm just giving you some background information. It occurs when the outcome can be any value in an interval, and it is never represented by a histogram. It's always represented by a curve. Okay, so here's what you need to know. This is what will be on the test. This right here is called negatively skewed. Negatively skewed. See how it has an extra part right here? This is called the tail. And is that pointing to negative or positive? It's pointing to negative. That's why it's called negatively skewed. Okay, so there'll be a picture like that on the test, and you'll have to say if it's negative or positive. Okay, this one has its tail right here, and where is it pointing towards? Positive. So this one's called positively skewed. Okay. All right, and this last one is called normal. Why do you think that one's called normal? Because it's even on both sides, okay? So this is kind of adding on to what we did last week. In the middle, you have the mean, which is the what? Average. And then you add a standard deviation or you subtract a standard deviation depending on which direction you're going. And then you add 2 standard deviations, 3, and so on. What's new is that in a normal distribution, they already have the percentages for you. The percentages are already done. So there are 34% of the numbers of the data between the mean and 1 standard deviation. So write that down, 34%. It's like a statistical fact. So 34%. So, and we'll be doing problems with that. So if it's normal, then 34% of the data is always here, and 34% is here because it is symmetric. It's the same on both sides. Yes. So go ahead and write those in. So if you add 1 standard deviation, you have 34% of the data here, and if you subtract 1 standard deviation, you have 34%. What's 34 and 34? 68. We know as well. This one is 13.5%. 13.5%. So what do you think this one is right here? 13.5. Okay. Yes, yes, they all will. Then the next ones, they get smaller and smaller. As you can see, the curve gets lower. This one is 2.35. 2.35. And this one is 2.35. And the last little bit is 0.15. And so what is this last little bit? 0.15. Okay. And we'll be doing problems with those today, and it'll make a little bit more sense what to do with them. Okay. All right, anybody need more time to write? Okay, all right. These next graphs, I'm going to go through really quickly, so if you're a slow writer, I'll let you copy my notes after the lesson today, but we're going to go through this pretty quickly. Right here, we're just making a histogram, so we're going to put the values down here, so 22, 23, I need to go all the way to 29, 22, 23, 24, 25, 26, 27, 28, 29. All right, so the values go at the bottom. And then on the side, you put the frequency. So I need to go all the way up to 5. 1, 2, 3, 4, 5. And I'm kind of going to make a bar graph, but it's actually called a histogram because the bars, well, let me give you the exact. A bar graph is when you have categories, like we talked about this the other day, like people's favorite color, blue, red, green. So it's technically called a bar graph if you have categories, and it's called a histogram if there's numbers on both sides, if you care, which you probably don't. All right, so 22 needs to go up to 4, and you make a bar. I don't care if you shaded it or not. There's no bar for 23. What about for 24? What should it go up to? 5. And then for 25, it should go up to 4. 26, there's no bar. 27, it goes up to 3. And 29 goes up to 2. Okay, once again, I don't care if you shade it in or not. Okay, if you kind of draw a curve, does it have a tail? Yeah, and where's the tail pointing? Positive. So this one's called positively skewed. Okay? That's fine. Okay. Okay, if you are not done with this, I will let you copy mine later, all right? But I want to move on. All right, this next one, what do you think goes on the bottom? The price. So less than 100, 100 to 120, 121 to 140, 141 to 160, 161 to 180. Feel free to turn your paper sideways. 181 to 200, and greater than 200. All right, so the price goes on the bottom. All right. And what do I need to make sure the other side goes up to? 12. 1, 2, 3, 4, 5, 6, 8, 9, 10. Yes, yes, sir. Okay. All right, so for 100, there's no bar. What about for 100 to 120? Goes up to 1. 121 to 140, it goes up to 3. 141 to 160 goes up to 7. 1, 2, 3, 4, 5, 6, 7. 161 to 180 goes up to 8. And then the next one goes up to 9. All right, and then the last one goes up to 12. Thank you. Okay. All right, if you draw this one, does it have a tail? Yes, and the tail is pointing negative. So this one is called negatively skewed. Okay, again, I will let you copy my notes later if you don't have it done and you would like it to be done. Okay, this last one, what should go on the bottom? Shoe size, very good. So that's going to be 4, 5, 6, 7, 8, 9, 10. And what do I need to make sure the side goes up to? 8. 8's the highest. So as long as you have 8 hash marks, 2, 3, 4, 5, 6, 7, 8. Okay. All right, so 4 goes up 1. 5 goes up 2. 6 goes up 4. 7 goes up 8. 8 goes up 5. 1, 2, 3, 4, 5. 9 goes up 3, and 10 goes up 2. Technically, you have to do the bars, but I mean, do I grade your notes? Yes. You're not going to have to make one of these on the test. Okay, what are your thoughts on this one? Normal. Why is it normal? It's even on both sides, okay? So it's normal. Okay. We are also going to add in, you have space in the corner right there. We're going to go ahead and draw one of these and talk about that. So we're going to draw a normal curve. And in the middle, we're going to need the mean. All right, in the middle, we're going to need the mean. How can we get the mean? So in the calculator, let's go to stat, because there is going to be one of these questions on the test. So when I go to stat, edit, what am I typing in? Very good. L1 would be shoe size, but be careful. So what do I type in first? What number? I think you just said it right. So I need to type in a 4. So there's a shoe size of 4. How many people have a shoe size of 4? 1. I just type in 1, 4. But then for 5, I have to type it in twice because there's 2 students with a 5. Okay? And then you have to type in 6 4 times. And you get it. You get the pattern here. And then 7 8 times. All right, those are the correct numbers up there. So on your paper, what we care about is the mean, which is 7.24. So let me write that down. 7.24. And then when I go 1 standard deviation that way and 1 standard deviation this way. So we kind of did this last week. So the mean is 7.24. What do I have to add to get the 1 standard deviation away from it? 1.5. So my standard deviation is this symbol, and it's 1.5. So I have to add 7.24 plus 1.5. And then to get this one, I would have to subtract 1.5. What is that? Is it 5.74? Okay. All right. And then if I wanted to go another standard deviation, I would have to add 1.5 again. And what would I have to do over here? Subtract 1.5, okay? We're not going to spend time doing that. But if it is normal, you automatically know that 34% is here. And how much is here? 34%, okay? And this is, and we'll do more of this in a minute, but I just kind of wanted to give you a picture, okay? All right. All right, stretch break. Yes. Use the normal distribution curve. So on the test on Friday, as you know, on the test, all the problems are mixed up. When you see normal curve, that's when you need to draw one of these, okay? A normal curve. When you see that in the problem, when it says normal curve, it will say that, okay? Here's our particular problem. The shelf life of a particular dairy product has a mean of 12 and a standard deviation of 3 days. So in the middle, you put 12. They've already told you what it was. The mean is 12. They also already told you the standard deviation was 3. So go ahead right now and draw 3 lines. 1, 2, 3. Doesn't have to be perfect, but draw 3 lines this way. And do 3 lines this way. Okay? 3 lines in both directions. Okay? Now, To get these numbers, doesn't matter. To get these numbers, I'm going to add 3 in this direction. What am I going to do in that direction? Subtract 3. So this gives me 15, 18, and 21. So we're just adding 3s. And then in the other direction, it gives me 9, 6, and 3. Okay? Now, without looking at the other side of the paper, what percentages go right here? 34. Very good. So 34% and 34%. Please fill it in for this problem. 34 and 34. Without looking, does anybody remember the next one? 13.5. 2.35. Very good. Okay. All right, I'm going to give people a few more seconds here. Okay. All right. What percent of products last between 3 and 12? So you don't need to make this hard. So between 3 and 12, I need to add 2.35, 13.5, and 34. You just add, nope, because it's between 3 and 12. That's less than 3, okay? I want between 3 and 12. So 2.35 plus 13.5 plus 34. What you got? Okay, so that's the answer because it said what percent? 49.85%. Okay, all right. What percent of products last between 6 and 21? I take the numbers in between them, and what do I do with each of them? Add them up. So 13.5 plus 34 plus 34 plus 13.5 plus 2.35. Okay, so you add up your percentages. What you got? 97.35? So yes, because between 3 and 12, I put my hand here and my hand here. Okay? All right. This last one, what percent of products last more than 18? So here's the line for 18, and more than would be 18 and up. So it'd be 2.35 and 0.15. Okay? Which gives you 2.5%. Okay? All right. So on all 3 of those questions, it just said what percent. And so that's all we had to do. Okay? All right. Does anybody have a question on this one? Okay. All right. On the next one, the scores on a test given to 150 employees have a mean of 100 and a standard deviation of 15. So I'm going to go ahead. So in the middle, Ashley, what number would go in the middle? 100. And then you just do 3 lines. 1, 2, 3, and 1, 2, 3. Every time. It doesn't matter what it looks like. It doesn't matter. Shh. All right. All right, so Ashley, 100 goes in the middle. How do you get the next number, Ashley? You add 15. Okay, so this gives me 115, 130, 145, 85, and 55. Okay? So you add 15 in one direction, subtract 15 in the other. Okay? All right, again, it's going to be 34 and 34, 13.5, 13.5, 2.35, 2.35, 0.15, and 0.15. Okay? Okay. First one, how many employees scored less than 115? So here's 115, and I need less than that. So I'm doing 0.15 plus 2.35 plus 13.5 plus 34 plus 34. Okay, so that's what I'm doing first. Everything less than 115. So always get your percentage first. Yeah. All right. Find your percentage first. So you add those up. Anybody got that? 84. Okay. That's 84%. So these green numbers are all percents. What does the question ask for? How many employees? Okay. So 84% of 150 employees. Look, that's up here at the top. Okay, so what I need to find is 84% of 150. That's what I need to find. All right. In math, 84%, sorry, in the calculator, you'd have to type that in as 0.84. And then in math, what does of mean to do? Multiply. Of means to multiply. So you would multiply by 150. Okay, so that's how you get your answer. So 126 what? Employees, people. Good. Okay. All right. Part 2, how many employees scored between 55 and 85? So first thing I do is find my percent, 55 to 85. So I need to add what? 2.35 and 13.5. All right, that gives you, okay, that is 15.85%. What does the question ask? How many employees? Okay, so I do 0.1585. I'm going ahead and moving my decimal. Times how many total employees are there? 150. Okay, so you get, what does the calculator exactly give you? 23.775. So if you put that, I will count that right. If you put 23.8, I will count that right. I will also count right 24 on this one. Why would I count 24 right too? You can't have a decimal employee. So if you want to, you can argue this one either way. I'll count both ways right. What? Right. Okay. So 24 is fine. If you want to stick with the decimal because that's what we've been doing, that's fine as well. Okay. All right. How many employees scored greater than 130? What am I adding? Okay. So that gives me 2.5%. Let me call on somebody. Eden, is that my final answer? No, because it's asking how many employees. Cecil, what would I have to do to 2.5%? And it becomes what? 0.025, because you move it 2 places and there's an empty spot. Okay? 0.025 times 150, because I want 2.5% of the 150 employees. Anybody? What? All right. Or 4. Either way is fine. Okay. All right. People at a local lake resort prefer the lake to have a specific surface temperature. The lake's temperature is normally distributed with a mean of 82 and a standard deviation of 4.2. So, all right, draw that. All right, Cheyenne, what number is going in the middle? The mean always goes in the middle for normal curves. And Cheyenne, how do you get these things? What do you have to do? You've got to take 4.2 and add it. And then what do you do in this direction? Subtract it. Okay. So you take 82 and you add 4.2. Anybody? 86.2. And then you add 4.2 again. And then you add it again. Okay. And then to go in this direction, you take 82 and you subtract 4.2. And then $69.4. Okay. Okay. Same old. 34, 34, 13.5, 13.5, 2.35, 0.15, 0.15. Okay. Okay, this one has a twist, but you still start it the exact same way. If 80 people prefer the temperature to be at least 86.2, how many people are at the resort? So let's start with this. At least 86.2. What does at least mean? That or more. So we go to 86.2. And we need more than that. So the first thing I'm going to do is add 13.5, 2.35, and 0.15, like we always do. 13.5 plus 2.35 plus 0.15. Okay? That's 16 what? Percent. Thank you. All right. Now, here's the kicker. 80 people prefer the temperature to be at least 86.2. How many people are at the resort? Is 80 my total or is 80 like my specific portion? It's your specific portion. So 16% of the total, 16% of whatever the total is going to give me 80. Let me say that again. So 80 people prefer it to be at least 86.2. Well, 80 we already figured out was 16%. So 16% of the total is 80, okay? Now, to make this a math equation, it's really simple. 16% becomes a decimal. I don't know the total, so I put an X equals 80. And I only have to do one more step to finish it, okay? Divide it. Because 0.16 times x, the opposite of multiplying is to divide. So I divide both sides by 0.16, and I get what? So that's 500 what? People total. Okay, so total people. So let me just recap to clear up some confusion. On the problem we just did, we knew the total. So when you know the total, you just multiply them. Your decimal times the total. You just multiply them. If you don't know the total, that's when you have to put an X and divide. Okay? So those are the two things to keep straight. All right. You do 80 divided by 0.16. Okay. All right. If 611 people prefer the temperature to be between 77.8 and 90.4, how many people are at the resort? So, Jonathan, what do we need to do first? Good. Find the percent between 77.8 and 90.4. So, Jonathan, what do I add up? No. It's between them, okay? All right, so somebody tell me what that gives us. What? Thank you. And that's 81.5%, okay? 611 people prefer the temperature to be between 77.8 and 90.4. Is 611 my total? No. So when I don't know my total, I'm going to go ahead and make this a decimal, 0.815, and I put an X. Whenever I don't know the total, I put an X, and it's going to equal whatever other number you have, 611, okay? When you don't know the total is when you put an X. The total always goes in this spot, all right? Jasmine, what do you have to do last? Divide. Anybody? Okay, so we'll just say 75. No. All right. If 24 people prefer the temperature to be at most 90.4, how many people are at the resort? Autumn, what does it mean by at most 90.4? Good. That's as far as you can go over. So here's 90.4. It's everything to the left. Now, you can do it the way we've always done it. You can add these up, or you could take a shortcut. Very good. 100 minus those. Okay. All right. So, however, yeah. Okay. So if you add them up like we have been doing, 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5. All right. 97.5%. Okay, so that's not my final answer. Mason, how would I set up what would my next step be? Uh-huh. Good. Okay. And Sterling, what do you do last? Yep. Anybody? Anybody need more time? Okay, last one. In a set of test scores, they are normally distributed. A test score of 76 is 3 standard deviations below the mean of 85. What percent of people scored between 82 and 94? Denise, if I were taking a test, what would I need to circle? Bless you. What would be the key word on the test? That would be important, but anybody? Very good. Normally distributed. So again, on the test, all the questions are going to be mixed up. So that's the part that tells me how to start it. When I see that on my test on Friday, I then draw that. Okay? So that's kind of giving you a helpful hint over the test on Friday. Okay? So what's the mean on this one? 85. Tells you that right here. Mean of 85. Now, here's the twist on this one. What else do you know? You know one other thing. Well, no, you don't know anything about that yet. Okay. 76, you kind of have to read all this together. 76 is 3 standard deviations below the mean. Okay, Austin, hop down. If you want to sit in your desk. 76 is 3 standard deviations below the mean. So you go 3 lines below, and what number do I know is right here? 76, okay? Now, some of y'all can do this in your head, but please don't shout out. Let me help people who don't do it in their head. I need to figure out what this gap is. What could I do with these 2 numbers to figure out the gap? Subtract them. 85 minus 76. 9. So from here to here is 9. And then how many rectangles do I have? Divide it into 3 rectangles. Gives you 3. So 3 is my standard deviation. Each of these is going by 3s. So I need to do 85 minus 3. What's that? 82, and then 82 minus 3, And it's 79 minus 376? Yeah. Okay. So I'm going from, now I can answer their question. What percent were between 82 and 94? I do look like I'm going to have to go in this direction a little bit. So what would this number be? 88, 91, and 94. Okay. All right. So to get the percent, I'm going to add 34, 34, 13.5, and 2.35. Anybody? Is that my final answer? Why? It said what percent. So you're done. Okay.